Good morning. So today we are starting our lectures. We are dealing with the topic known as vertical alignment. Okay. In highway engineering, there is a topic known as vertical alignment. What do you mean by vertical alignment? So vertical alignment means we have to fix the vertical profile of the highway. Okay. Before starting a design purpose or before starting the construction, in the design stage itself, fixing of the vertical profile of the road is very much important. Now the question is, what is meant by vertical profile? What do you mean by vertical profile? So when we are speaking about vertical profile, there are two important components in vertical profile of road. One is gradient. What do you mean by gradient? We'll discuss in detail. You might have heard about gradient. One is gradient and the other one is vertical curve. So these two will together constitute the vertical profile. Okay. So they can write like this. Vertical alignment, and this vertical alignment is composed of two things. One is gradients and the other one is vertical curves. So vertical curves and gradient will together constitute the vertical alignment. Now when you speak about vertical alignment, how this vertical alignment is represented? Okay, in terms of highway engineering, if you have to represent the vertical alignment can be represented in the form of a graph. In the form of a graph means the vertical axis of the graph will be showing the elevation and the horizontal axis of the graph will be showing the distance from the center line of the highway. So if you are making a plot, the plot is made with distance from the center line of the road on the x-axis and elevation on the y-axis. You get a plot, and this plot you can use to represent a vertical profile or a vertical elevation or a vertical grade. Okay, so this vertical profile will be composing of two things, or vertical alignment will be comprising of two things: gradient as well as vertical curve. Now what do you mean by the term gradient? Okay, here we have written about gradient. What is this gradient? We can say that gradient means the rise or fall, rise or fall of a vertical profile. You call it as the gradient. For example, if you are considering the vertical profile of a road, okay, if you are considering the vertical profile of the road, you can see that at some points there will be rise in the vertical profile, at some points there will be fall in the vertical profile due to many reasons. There are different reasons which will be causing this variations in the vertical profile. Okay, I'll show you one. Okay, so this is one material showing the chapter vertical alignment. So here it is written that the vertical alignment of a road will be consisting of gradients and vertical curve. We have seen that gradients and vertical curve will together comprise the vertical alignment. Now this vertical alignment can be usually drawn as a profile. Okay, you will be drawing this vertical alignment as a profile, that is a graph with vertical axis or y-axis showing the elevation, and on the x-axis or the horizontal axis there will be the horizontal distance along the center line of the road. So if a plot like this is obtained, you can plot graphically the vertical alignment. Okay, so we have seen about gradient. What is meant by gradient? Gradient is the rate of rise or fall along the length of the road with respect to horizontal. Rate of rise or fall along the length of the road with respect to horizontal, we call it as gradient. So for designing the vertical curve, we need to decide the gradient. So before the gradient is finalized, okay, there are many things that need to be, many factors are need to be taken into consideration before a gradient is finalized. What are the factors that need to be taken into consideration? One is the construction cost. Okay, in some cases, the geography of the particular location is such that Just a minute. Okay. Geography of the particular site is such that it will be favoring cutting to some site. At some areas, it will be favoring filling. So depending on the geography, okay, that is why we call it as depending on the construction cost. So construction cost will be decided by one factor is how much amount of cutting is required, how much amount of filling is required. So based on the construction cost and based on the vehicle operating cost and several other factors, it will be decided that how much should be the gradient to be provided. Okay, gradient is also decided by the topography of the area. What is the particular area type? Okay, so these are several factors which decide the fixing of gradient. Okay, so usually it is said that steep gradients will be avoided because if the gradient is very steep, you know that it will be very difficult to climb up the slope. Okay, at very steep gradient, it will be very difficult for the person to use the vehicle or even as a pedestrian to climb up the gradient. So usually steep gradients are avoided. And the construction cost will be increasing very highly if the gradients are steep. Now, what are the effects of gradients? The effect of long steep gradient on vehicular speed is considerable. Particularly important in case of roads. Okay, this is particularly important in case of roads where the proportion of heavy vehicles is significant. Now, how we will be representing the gradients on the road? I told that gradients will be of two different forms. It can be either positive gradient or ascending gradient, which shows that climbing up the hill. In some cases, the gradient will be negative or descending gradient, which shows that climbing down the hill. So positive gradient or uphill gradient will be represented as plus n. Here you can see that it is represented as plus n, and negative gradient is represented as minus n. The deviation angle comes into picture when these two different gradients, a gradient moving up and a gradient moving down, is meeting at one particular point. You call it as the deviation angle. Okay, so this deviation angle can be measured or can be given by the algebraic expression n1 plus n2. For example, I can show you. Here you can see that this one, I hope it is clear. If you want, I can zoom it more. Okay. Now please observe this figure, all these figures. In figure A, there is one up gradient that is plus n1. It is denoted as plus n1. And there is another gradient which is also in the positive direction. So the deviation angle means from this gradient you are drawing a tangent, from this gradient also you are drawing a tangent, and the angle at which both these tangents are meeting, you call it as the deviation angle, that is represented by capital N. So the deviation angle can be written as plus n1 minus n2. Now consider another case. Here there are two gradients. One gradient is plus n1 moving upwards, and another gradient is, if you are drawing a tangent, it is coming as the deviation angle itself. Here you can see that there is one slope that is moving upward as plus n1, and another gradient is in the negative direction or is in the descending direction, that is denoted as minus n2. So the deviation angle can be written as capital N is equal to n1 minus of minus n2, that is n1 plus n2. Okay, so that is the how the deviation angles can be written. Okay, next one. So this is how the representation of a gradient is happening. For one vertical unit, it will be n horizontal unit, 1 in n, and for n vertical unit it will be 100. So there are certain specifications from the Indian Road Congress, IRC specification for gradients at different roads. Depending on the terrain may be plain or rolling terrain. If the slope angle is between 0 to 20 degree, it will be plain. It is between 20 to 35, it is rolling. Then depending on the slope angle, plane or rolling, hilly, steep, etc., there are different types of terrain. And for different types of terrain, there are different gradient values given as. For ruling gradient, this is the value. Limiting gradient, this is the value. Exceptional gradient, this is the value. Now your question will be, what is meant by this ruling gradient? What is limiting gradient? And what is exceptional gradient? We are going to see. Ruling, limiting, and exceptional. Now, let us see the types of gradients. For depending on the terrain, IRC, Indian Road Congress, has specified the desirable gradient for different terrain. Okay. So what are the different terrains, or what are the different gradients specified by IRC? Ruling gradient, limiting gradient, exceptional gradient, and minimum gradient. These are some of the important gradients. Okay. So what are the different gradients specified by IRC? We can write like this: gradients as per IRC is ruling gradient, limiting gradient, exceptional gradient. Ruling gradient, limiting gradient, exceptional gradient, and minimum gradient. These are the different types of gradients. Okay. So ruling gradient means maximum gradient. Okay. Ruling gradient is the maximum gradient with which the designer is attempting to design the vertical profile of the road. That is the maximum gradient. Okay. If the designer is deciding that I will be designing this road taking into mind the maximum gradient, then it can be called as the ruling gradient. Now, there are different factors which will decide the what should be the gradient value. These different factors include what is the terrain, what is the type of terrain, then what is the length of the grade, what is the speed at which vehicles are moving, then how much is the pulling power of the vehicle, then presence of horizontal curve. These are the different factors which will decide the ruling gradient. Now, in case of flatter terrain, in some cases the terrain may be flat. In case of flatter terrain, you can be providing the flat gradients. But in some cases, the terrain will be hilly in nature. And in hilly terrain, it is not possible or it is not feasible to provide a flat terrain. Okay. So the adoption of ruling gradient are considered or as decided taking into consideration the following features. What is the terrain, length of the grade, speed, pulling power of the vehicle, etc. Okay. Next one is consider a situation. Consider a situation when the designer has decided to go for a ruling gradient. But the problem is the ruling gradient is not possible in that particular location due to increase in the cost of construction. If the provision of ruling gradient is making the cost of construction to increase by multiple fold, there is a multiple fold increase in the cost of construction due to provision of a ruling gradient. So in such a case, there will be adoption of another type of gradient known as limiting gradient. Next one is exceptional gradient. In unavoidable situation, okay, the situation is so that very steeper gradient need to be provided. It is an unexceptionable situation or unavoidable situation where the steeper gradient need to be provided. But the thing is that such a steep gradient should not be provided for a considerably long length of stretch. Okay, maximum for 100-meter stretch, you will be providing such steeper gradient. Okay, so that is known as a exceptional gradient. So we have seen ruling gradient, limiting gradient, exceptional gradient, and another one is the minimum gradient. Okay. The minimum gradient means there is no need of gradient considering the geography of that particular area, but a minimum amount of gradient need to be provided taking into consideration the surface drainage. Okay, surface drainage we have already seen about camber or super elevation. Camber or super elevation means you are rising the inner edge of the pavement with respect to outer a bit higher so that proper drainage is made possible. Similarly, in order to facilitate the easy drainage, a minimum amount of gradient need to be provided. That is known as the minimum gradient. Okay. So we have seen that there are different types of gradients and what are the situations in which these different gradients are provided. So what are the different gradients? One is ruling gradient, another one is limiting gradient, third one is exceptional gradient, and another one is minimum gradient. These are the four different gradients provided, and we have also seen what are the situations in which these gradients are provided. Okay. Now we are going to discuss about a new topic known as grade compensation. Grade compensation. So what is meant by grade compensation? We have already seen that there are different type of gradient and what is the situation under which these different gradients are provided. We have already seen all these things. Now, grade compensation means a particular roadway is in such a way that it is provided with one particular gradient. Okay. Consider a situation in which there is a curve coming. Okay. You have a roadway and you have a curve. Sorry. Okay, the roadway is with a curve and already there is a gradient provided to this particular roadway. So if there is a gradient, then definitely the tractive force or the force required to pull the vehicle along this gradient will be higher. Okay. When you consider a road stretch without a gradient, and you have two kind of roadways, one is without a gradient and another one is with a gradient. Even if you are walking, if you are climbing up a hill, you know that the tractive force or the force required to climb is more. Similarly, the case with vehicle also is same. If there is a gradient that is moving ahead, there is an upward gradient, then the force required to climb will be more. So now the situation is like that. You have to negotiate a curve and this curve is having a upward gradient. So the force required to negotiate this curve along with this upward gradient will be very high. So in order to reduce the tractive force, required to climb up when a situation is arising due to a curve provided, okay, you need to undergo something known as a grade compensation. So this grade compensation will come into picture when you have a curve along with the, and along with the curve there is one upward gradient. Okay, you have a curve and a up gradient. Now, grade compensation means you have to compensate the gradient or you have to bring about a reduction in gradient. And this reduction in gradient is required to overcome the tractive force required. In case of curve. Okay. Now, how can this gradient be provided or how can this grade compensation be provided? Let us see. There are three ways, or these are the following specification as per IRC for the grade compensation. If the gradient is less than 4%, if the gradient is less than 4% means it is not a higher gradient, so that there is a very large loss in tractive forces not coming into the picture. There is no such case that there is a large requirement of tractive force. Okay, the gradient is coming at a value of 4%, which does not need a very high tractive force. So in such a case, a grade compensation is not required. There is no need of grade compensation. The grade compensation is 30 plus R divided by R. If there is no grade compensation provided, then the slope is flatter than 4%. But you have to provide a grade compensation. So grade compensation will be provided using the expression grade compensation is 30 plus R divided by R, where R is the radius of the horizontal curve. And the maximum grade compensation is limited to 75 divided by R. Okay. So this is how you will be providing grade compensation. I'll tell once more why grade compensation is provided. We have already seen how grade compensation can be provided. If the slope is less than 4%, there is no need of providing grade compensation. In case you have to provide grade compensation, then grade compensation will be provided like this. Grade compensation is equal to 30 plus R divided by R, or maximum grade compensation is 75 divided by R. Okay. So this is how the grade compensation will be provided. It will be more clear if you are doing some numerical problems. If possible, tomorrow we will be solving numerical problems in a live session itself. Okay.